Right, so now you've had a go at this. Let's see if we can deduce what this range of values of k actually is. Now, notice we've got an equation set up, 1 plus 2 cosec x equals k. So if I just write this down, so this is for part C here. We've already drawn the graph of y equals 1 plus 2 cosec x. Now then, and we're interested in also where this graph, 1 plus 2 cosec x is equal to k. So we could also consider the graph of y equals k, because these two expressions, and what I mean is k and 1 plus 2 cosec x must be the same. So if we sketch the graph of y equals k on the graph we've already got, then we should be able to deduce the range of values of solutions. Now, y equals k is, of course, a horizontal line. You'll know this from lower school because k is just a constant. Okay, so we can just add a horizontal line anywhere. We don't know the value of k. Obviously, if k was 1, we'd have a horizontal line passing through y equals 1. And if k was equal to 10, it would pass through 10, and so on and so on. So all we need to do is add a horizontal line to this graph. Now I can do that. Let's choose a nice pretty color for the line. So I'll do it across here. So this purple line here, this is going to be my line y equals k. Like so. Right, now, because I don't know what the value of k is at the moment, from where I've just placed it arbitrarily on the board, it's somewhere below 3, isn't it? Now, if I just move it up slightly, which I should be able to do. Yes, there we go. So I can just move it up to 3. So at the moment, that's y equals 3. If I put it here, I've got y equals 0, y equals -1, and so on and so on. So the question is, what range of values will give me no solutions for when this line is equal to 1 plus 2 cosec x? Well, we can see it quite easily. If I just move this line up to somewhere around here, we just have to look for the number of points of intersection with the graph that we've just drawn in that range from -2 pi to 2 pi. So if you just look at that, at the moment, we've got how many points of intersection? Well, we've got 1, 2, 3, and 4. Okay, it doesn't remember it doesn't intersect the asymptotes. They're just points on the x-axis where the graph is not defined. So there's 4 points of intersection there. Now, as I change this value of k, so if I make it less, I've still got 4 points of intersection, but I can reduce the number of points of intersection by setting k equal to 3, okay, which is where my minimum point is. I know I'm not drawing it perfectly, but you can see I've already got the two highlights here, there and there. We can see we've got points of intersection at -3 pi over 2 and pi over 2. So that means we have 2 solutions to the equation, but we want no solutions. So it says clearly in the question, no solutions. Well, if I want no solutions, all I have to do is make k anything less than 3, because the line is not intersecting the curve 1 plus 2 cosec x at all, but only so far, because if I go down to -1, I'm back to 2 solutions again. So you can see here I've got solutions again at -pi over 2 and 3 pi over 2. So we can see that there's a range of values of k for which there are no solutions. So it's anything less than 3 but greater than -1. So we can just write down the answer. So for k, I've just done that wrong. So k, sorry, no, it was correct. So k has to be anything between -1 and 3, and there will be no solutions to that equation that was given. Notice equality is not permitted. if we were given equality, or if I'd have stated equality, so if I'd have put that, it would be wrong, because you can tell that there are two solutions when k is -1, and there are two solutions when k is 3. So it's a strict inequality. Okay, so that's the answer to part C.